All right, everyone, we are back, and we are going to do our thin-walled pressure vessel problem. So, polymeric cylindrical system, diameter, length, thickness, material is the orange curve, right at the full stress strain tensor. So it's a polymer, so we know that our Young's modulus is equal to 1 times 10 to the 9th Pascal. Nu is equal to 0.4. Excellent. We need to check if R over T is greater than or equal to 10. And actually, let's go ahead and start to plug in some values and verify that. So I'm looking at my prep. So diameter, so that means it's 25 millimeters. Length doesn't matter. Thickness is 1 millimeter. This is 1. This is 0.4. I quit my kernel right before starting this problem. So I need to wake it back up. Let's check if we're R over T, because then we can figure out our stress tensors. Here we go. Here we go. Here we go. Let's get this show on the road. Yep, so we are indeed thin-walled. So R over T is greater than 10. So our stress tensor will be, for this problem, sigma H in the 1, sigma L here, epsilon, same thing, hoop longitudinal. Orange material starts to yield. So I'd say the yield looks like about 5%, but that's 0.05. If it's yielding, that's going to be in the hoop direction. So let's start to kind of write out our problem. So this is our sig H, sig L. Our epsilon H yield is going to be 5 times 10 to the minus 2. Oops. 5 times 10 to the minus 2. Excellent. So that's our strain at yield. So I need to figure out when does EHY equals my, when does it equal my EH equation? So I've solved this. There's no temperature changing in this problem. So that's going to be when our delta P is equal to this. So we solve for that delta P. Now we know what our sig H is. Now we know what our sig L is. We know our EH is going to be this. Makes sense. And there we go. The strain in strain gauge 2 will be the EL, which is this right here. Fantastic. So we've done this problem. We've done this problem. It will yield via the von Mises criteria. Is that a valid claim? So von Mises, we know that sig 1 is equal to sig H. We know that sig 2 is equal to sig L. And sig 3 is equal to 0. And our von Mises criterion is going to be the square root of, actually, 1 second here. Oh, I'm getting my equation. In terms of our principal stress values. So yeah, let's go. It's going to be square root. Oops, where are we at? Square root of 1/2 times. So it's going to be sig 1 minus sig 2 squared plus, let's keep it in here, sig 2 minus sig 3 squared plus, let's see, sig 3 minus sig 1 squared. There we go. So that is our von Mises. So basically we're asking, will the material yield via von Mises? So basically we're saying, is our sig effective greater than our yield strength in this problem? Well, let's see. Our material really isn't. We don't necessarily have the yield strength of our material here. So we can't effectively, well, actually, we have, let's see here. We have the strain at yield. We've found sig H. So not a bad one would be to kind of see if this is our von Mises criterion. Well, yeah, that's a tricky problem. We really can't solve this because we don't have essentially that yield stress. So we can't really answer this question. Maybe you compare it to this, but that doesn't really make sense. So we would need the yield stress of this material to actually figure that out. So that's an unknown. We need to find that. Is the analysis valid? Yeah, that should work for polymers. So fracture diamond curve, correct? Nope, not unless there's impurities or defects. So it needs to look like this. I have initial crack size of this, surface tension of this. I'm not going to use surface tension because it's a polymer. I will use our OR1 criterion, which is square root E G sub C over pi A. So here we actually can do a good comparison because I can say that A naught is equal to 0.7 times 10 to the minus 3. My G sub C is equal to 197. We have that, so I'm just going to say square root of y times G sub C divided by pi times A naught. Oops. So this is going to be my or. So that's going to be my OR1. So now we're just basically saying, is our sig H greater than our OR1? Yep, so we are for sure failing in this system. So we are definitely going to fracture, or this material will definitely crack. All right, there it is. That's the end of the problem. See you next time. Thanks.